I will try to explain why software-defined vehicle is more than a buzzword, and as I think you all have a background one way or another in microwave, in radar, I hope to make clear as well why the car of the future, the software-defined vehicle, actually has a lot of expectations or demand for communication and sensing with microwaves. So that being said, let me start here, and thanks for your kind words. So I'm not a radar expert. Therefore, you will not see any fancy, I don't know, charts and graphs on radar, but this is about the market. This is about the applications. And this is also about the changing environment. So let me start there, because you can see I'm an old guy. I've been in this industry for almost 40 years, and at least for the last 20 years, the automotive industry has shown a really linear growth. Every year, more vehicles being made, more vehicles being made. It was very predictable, in fact. Now we find ourselves in a situation where that might have stopped, maybe completely, maybe forever. Maybe less cars will be made in the future, but different cars. So that's one aspect that we need to cover when we talk about the vehicle of the future. Then this growth that all our business models have been based on could come from putting more things into the cars. And actually, it's something that we've been doing. At some point in time, there was some cars that had a front radar, right? But now, these days, we can say pretty much every car has one. And not just that, but even more additional radars or other sensors. But as a consequence, cars have been getting more expensive. There's a limit there as well. So again, not more of the same, but different. And along with that, and I will show you some examples how cars have become an extension of our digital lifestyle, a connected consumer device. And you expect your phone or whatever you have, your tablet, to be always up to date, to be always connected. But cars have not been. They need to be. And along with that, some very established fundamental principles of how vehicles are designed and made have to change. Let me spend a minute or two on that. Because as it's written on the slide, in the world we used to know, there was always a huge pressure on cost. And Alan mentioned that a little earlier. We're looking for cents, literally cents, in the bill of material, BOM. So one of these expressions that you can find everywhere is that, right? So how can we optimize, how can we take out cost? Even, and that's the downside, if as a consequence we create a lot of variance. And I had a discussion with one of our customers when I was in their factory, and the guy said, even if every person on this planet could afford this particular vehicle, which was a very expensive one, no two persons would have to drive an identical car. And I say that's insanity. That has to stop. And you will see a little later in this presentation why, and I hope you will agree with me. Another aspect has always been another three-letter acronym, SOP, start of production. So it's a very complex product, and all of the subcomponents have to be developed, validated, etc. And at some point in time, they have to come together, roll off the assembly line, and function miraculously all together. Not quite a miracle, a lot of work. And it has been a fundamental principle that SOP is cast in stone. You have to do anything to meet that date, because after that, vehicles are rolling the production line. There's no change. Because as well, from a business point of view, you spend money on the left-hand side here, on the development. And then, after this miraculous start of production, it's time to cash in. It's time for payback. Which means that in the business model, there is no money available currently to spend on updates and on improving the vehicle after it once rolled off the production line. So, not in line with consumer expectations, unfortunately. So some of these fundamentals have to change. These days, everybody says, well, That's why we need a software-defined vehicle. I've chosen this example here because some of these vehicles are on the road. But the company who made them is not a traditional car manufacturer. Tesla has approached the design of the vehicle with a very fundamentally different concept. And I will not read all of the stuff. You can read much faster than I can. And you probably know that they are doing a lot of things themselves with proprietary solutions that originally car manufacturers have not, let's say, even been capable of doing. They've designed these cars to be permanently connected devices that are providing data and are receiving data throughout their lifetime. And I will come back to the lifetime story in a moment. And by the way, as well, when you look at that's with the exception of the Cybertruck, which is not available in Europe yet, okay? But that's the entire product portfolio. So when I was talking about variants before, actually this is very much standardized, even under the skin. Because these are software-defined vehicles that follow a software lifecycle. So while the hardware, the things you can see, stop to evolve at this start of production. You can see it here almost in the center of the slide. But what you don't see is that also with the Teslas that are on the road today already, there is a continuous development going on after that. So the physical, the hardware stays the same, and that will be the last part of my presentation at the end. The question is how much and how long can it stay the same? But at the moment, the hardware stays the same, but the vehicle evolves and the vehicle improves, and new features and functions are being added with the question, who's going to pay for it, that I was raising a little earlier. But most car manufacturers don't even have that problem, because most other cars actually are not suitable for this. And you can see this illustration of a wiring harness, you know, of the way that all the devices, the electronic devices in a car are connected. Today, this is all mirroring different, let's say, organizations at the car manufacturer. There are different ECUs and different branches in the wiring harness for that subsystem or this subsystem, because all of these subsystems actually are designed as options. Because as I was saying earlier, this entire industry has been based on cost optimization. So if you order a new car, you are asked to specify what you want, and then the things you want, and by the way that you have paid for, are being fitted on the car, while others that you personally have as a buyer not chosen will not be put. And from that point of view, that avenue is closed. You will not later on be able to come to the dealership with your car and say, please fit whatever system on the car if it's not been there. It is economically not viable. So today, these cars are not software defined because the hardware architecture is the limitation. So that needs to be overcome first. Vehicles need to be designed differently. And again, I'll pick up on some of these points now in the following slides. But have a look. This pyramid that you can see is based and continues to be based on a distributed set of components. So if you keep in mind what I just showed with the wiring harness, and the components will still be there. Say the radars on the car, they are where they need to be. For example, in the corners of the car. You will not put them into a central, maybe spinning radar on the top. No, they will stay there. But the way they're connected and they are sending their information will be different, because we will go through aggregations in the zones into a centralized computer. And that will have a lot more computing resources, as well opening up new ways in terms of signal processing that were not possible before, because the computing power was not there. By centralizing it, you have more, let's say, horsepower to perform tasks. And as I said, a software-defined vehicle is a connected vehicle. Therefore, that centralized computer is as well a way to pipeline data through a connectivity hub, as it's called here, a telematics device, into the cloud, into the backend. So that as well opens opportunities to take data from, if I stay on the example of radars, right, from specific situations or from let's say, situations of interest, which then you can collect throughout the entire fleet. So that you can, from those models, from that data as well, improve your models in the backend, develop improved performance solutions, and send them back down in the vehicle, because the whole thing with the pyramid works both ways. And basically then you have a learning system. Given that you have that architecture, and that's happening. So this is an example that I can actually speak about. It's the ADAS domain controller for the new BMWs that will be launched next year in 2025. It's actually called an integration platform. Because now everything that is automation, everything that is ADAS on the car runs on this device. All of the sensors that you can see on the slide are connected to that device. And also, all of these sensors are always going to be on every car, no matter what the first buyer specifies. So we are on our way to this software-defined vehicle. But again, it means a fundamental change as well in architecture and a fundamental change in business model, because now the OEM, BMW in that case, will have to pay for all of these devices, no matter what the first-time buyer does. And they will have to find ways of monetizing then that money through additional features. And here, the software comes into play. I will not go into the details. It's just to illustrate that with the integration of compute, you also need to build an integrated software architecture. So working for Valeo, I will take a Valeo example, okay? But therefore, we have built a fully integrated ADAS software stack, which then takes data from the devices that were shown on the previous page, and actually whether then, in that case, it's our own radars or somebody else's. Of course, we much prefer our own, but the architecture needs to be neutral or agnostic to that. And it needs to allow that scalability that I was talking about, adding functions later. So the functions, the applications at the top here need to be abstracted from the bottom. And on the right-hand side of the slide, you can see the delivery pipeline. You can see the machine learning that I was talking about, getting data from the fleet, then improving or training your networks and sending that back. It's all there. So as a consequence, I'll go very quickly. This is not an advertising for Valeo, but as a consequence, we had to change as well our organization, because it's a new way of doing business. And this software stack I was just showing is a product, like the physical products have been as well. And we need to provide support to our customers, because it's a complex product, how to integrate that, how to test. So along with the software business, there's also a service that we need to bring and that we are providing to our customers. But it doesn't stop there. And this is an example from China. And we had a little China discussion with Guido at the lunch table too, that more and more we can see future trends coming from China, because Chinese consumers are even more demanding than we would be in this room, or we would be here in Europe and other parts of the world. And for them, the car is a connected device, very much like a phone or a tablet. So not surprising that phone makers like Xiaomi are now producing cars. Quite surprising, in fact, that they're producing good cars. So people who have driven the car, I have not. I've seen them, but not sat in them yet. Confirm to me, yeah, this is a very good car. But not only that, this is now seamlessly integrated with your, let's say, digital ecosystem and your digital lifestyle. That's very much the shape of things to come. So the world of, let's say, telecommunication and the world of automotive are converging. Now, with that, we are facing in the automotive industry challenges that actually do come and hopefully have been solved as well. in the telecoms world. But now, cybersecurity, and that's the reason why these updates are not, let's say, an option, but are mandatory, will have to be ensured for the lifetime of a vehicle. Not for the lifetime of a smartphone that you can probably throw away after a couple of years, but the average age of the vehicle fleet in Europe is 12.8 years, the average. So we need to think how we can provide cybersecurity to vehicles 20 years from now. And just think what the world was 20 years ago. So therefore, as well, what I was talking about in terms of number of variants, etc., or standards in terms of compatibility will play a key role to ensure that lifecycle maintenance. And the other aspect is that, that connectivity has been moving much faster. And as I was saying, these software-defined vehicles are part of a network, are a fleet that provides data and receives data wherever they are. So at least, let's say, as mobile as a phone, you are traveling with your car as well to far-off places. So I was showing the example of Xiaomi, to say the car as a phone on wheels, so to say. I don't like that analogy, but in that case, it's a phone maker making a car. In this case, it's a car maker making communication equipment. So here you can see that that Geely, a big automotive group in China, is now launching their own satellite network to have these software-defined vehicles permanently connected. So these are low Earth orbiting satellites, but they're not anyone else's. They're not relying on a telecoms operator. They're doing it themselves. And so, again, communication becomes an integral part of a software-defined vehicle. A different aspect now. I was speaking about adding computing, adding sensors, adding connectivity. And I said at the very beginning, in a market that is flat, in a situation where cars have already been, well, reaching a point, becoming expensive to a point where people cannot afford them anymore. While I said as well, option business is dangerous. We need to standardize the architectures. So one consequence you can see here, there's 3 German premium OEMs if you recognize the shape of the cars, okay? And the same pattern that they all said, sorry, we will not make any more small cars, or will not make them ourselves anymore. Because this technical solution is not easy to scale. So in terms of affordability, that is a big challenge. I'll talk briefly about the computing side now. And therefore, again, I can only speak about Valeo and not about other companies or suppliers. But for us, that has become a key issue. How do you scale such solutions to make sure that there's still affordable vehicles, even if they are software-defined? So you can see some pictures, some examples here. I'll not dwell further on that. But it means that, again, the architecture on the software side needs to match those scaling categories. So we've built not just the ADAS stack that I was showing before, but we've built a full software architecture solution that is based on the hardware at the bottom, the scalability that I was showing on the previous page, which also includes the devices like radars, cameras, and so on, or connectivity that needs to be on the car, an abstraction by an operating system that we call VOS, the middleware here in the center, and then the development of apps and services can be done and needs to be done on a completely different layer, abstracted from the bottom. So, as I was saying before, I'll not dwell on this. There are different business models behind. It's not the same business as before, and there are as well different ways of engaging with customers. Because as I was saying in the beginning, not everybody has all of the consequences that are necessary to make these complex systems work. So I will show you 2 examples. That's number 1, where we are also working in different ways with the car manufacturers. So this example is about driverless parking, level 4, So you can move away from the car, and the car will find its parking space and park itself just, let's say, based on detection on sensor information, based on the sensor set that I was showing to you before, based on, let's say, regulations globally in terms of reliability that is required for such driverless systems, based on connectivity, because it means we have to understand where the car is, what, let's say, ODDs are required, so the connectivity is part of that as well. Plus, what is quite interesting too is that we are generating, through a SLAM model, we're generating a map dynamically as the cars move, which is shared to the cloud backend. Remember my pyramid from earlier, then is being aggregated there and can be sent to all the vehicles in the fleet continuously. And we are doing that in a complete partnership with the OEM. So everybody is contributing their assets. It's not quite, let me say, open source, right? But it's a white box development that both sides have access to. It's completely new in the automotive industry. So far, everything was always black box, everybody protecting their IP. And the way to go forward is not like that. We have to be more open, we have to be more standardized. And then speed is actually what counts, right? And that's the second example. Again, you might have read about that. Renault is working on a new architecture that, guess what, is called SDV architecture. And you can see some of the logos here. So even companies like Google are now involved in that. It shows that the car is not anymore, let's say, a piece of metal with an industry that's completely on its own, but everybody has to be much more networked. I think it's getting clear from this presentation that industries and competencies are much more transversal these days. Now, a look behind and the life cycle story, right? Because it's nice to talk about, hey, new technologies, and it will be great, everything will be connected, and we'll shoot satellites into the space and so on. But then again, keep in mind what I said before. The average age of a vehicle in Europe is already 12.8. In Greece, if I remember, it's 17. Okay, I mean, we have an obligation to keep these cars on the road and safe as long as somebody is using them, okay? And even, in a different experience, I had the chance to fly on a plane which is almost 100 years old, from the 1930s. It was a very nice experience. It was a very comfortable flight. I felt perfectly safe. But I've seen other planes on the same occasion which were maybe 50 years old, and the engineers were telling me these planes will never fly again because nobody knows how to fix the electronics on a 50-year-old plane. So how will we fix the electronics of a car that is produced in 2024, in 2070, maybe even in 2050? What do we do in 2030? Even that is not a given, right? And it's not just classic cars as a hobby for some, let's say, privileged people. But I took this picture when visiting our colleagues in Cairo, where we have a team of almost 3,000 people. And there on the streets, you can see plenty of, let's say, quite old, but well-maintained cars that are providing a service every day. So it's not a hypothetical or theoretical problem. It's very practical. How do we keep these cars, or the cars we make at the moment, how do we keep them on the road and how we keep them safe? When, I think many of you will be working on software as well, and you will know that while you can compress it a lot, eventually you want more, you want more, you want more. So that's the point at the top. The hardware has a physical, let's say, limitation, right? But the software, you always want more, you can use more resources. If I could only do this. So at some point in time, you will exceed, and that's the green to red thing here, okay? You will exceed the capability of your hardware. What do you do? And I was speaking about Tesla. We can probably expect that at some point in time, Elon Musk will say, yeah, you can get full self-driving, but only up to hardware or from hardware X. So far, they're still saying, no, it's just a matter of software. It will come, it will come, it will come. But there are first indications that, the hardware that is on current cars might not be up for the job. So what? Okay? That's why we are convinced, I am convinced, we also need to rethink that. The software-defined vehicle is still made of hardware. And as the software and the appetite of consumers keeps growing to have more, we have to find ways of upgrading the hardware as well. You cannot rip out all of the wiring harnesses and all the stuff, but we have to have a backbone architecture which will kept stable. And then what I call cartridges, on this slide here, what we see here at the top in the kind of darkish blue, are physically, let's say, bricks, pieces that you can remove and upgrade. And we're actually working on such a product that will go in production with one of our customers. And that will also tear down some of the silos in the organization that I was speaking about earlier when showing the wiring harness. So for example, domains like ADAS and infotainment that were in separate departments, on separate boxes, etc., will converge. Because that compute architecture centrally, it will have to be scalable, it will have to be independent. And then when you tear down these walls, new opportunities are opening up. So no time and no technical capabilities to show you what really is happening, because every one of them is kind of moving, okay? So the panorama means that you can use video streams from a car on the move, and to, like in a video or in a, say, a Zoom call or a Skype call, transmit video to people elsewhere that can see where you are, what you're doing at the moment. You can share, nice moments from your vacation with your family who's left at home, etc. Connectivity, detection, communication. Teleoperation, same thing, okay? Connect to a vehicle, but of course you will use as well the sensors on the vehicle to understand what is it safe to do or not, and then control the vehicle remotely. Again, we have this up and running on serious hardware. All of this, serious hardware, but software. And the last, that's called Valeo Racer here, the picture is not very clear, but that's gaming in the car. So you can see on the screen the surroundings that you're driving, and you can interact with that, which is a very fun way of spending time on a car. And again, it's just software. So software will shape the future of the car, that's clear. But as I wrote here, reliable and upgradable hardware is mandatory nevertheless. And that hardware in many ways will depend on, let me say, microwaves, microelectronics as well, to enable higher bandwidths, to enable lower cost for those devices, and to keep cars fun to drive while they're safe on the move. And with that, hopefully you see it's more than a buzzword, it's a technical challenge, it's a challenge of business models, but it makes the car and the car industry a very exciting place to be. Thank you very much.
Thank you very much for this very interesting speech. So yes, we have questions, please.
Or maybe if you speak loud, I will repeat the question for everybody. Okay? Okay.
Well, first of all, not a question, but really, thank you very much for this wonderful talk. I really loved it, and you said it's not really that. I'm already enough. I'm glad I could hear a story like this. Thank you, and very interesting, and I have to say it blew off my mind, a lot of the things you said, because it made me think on a philosophical level, I think more than a technical level. It generated a lot of, thinking about, all what you have said and the consequences of this change that you discussed, I think, for the vehicle market, but it's equally applicable to many other fields, And for example, I was thinking, because now you say that this software-defined vehicle is the future, and basically companies who make mobile phones, become, car makers, And, but a car still will need an engine, right? So where is the, boundaries to some extent of keeping, for us also as a society to keep certain competencies, like you said, not only about, being able to still fix some type of older cars in the future, but also still be able to manufacture a car which, okay, might still be software controlled, but it needs an engine, at least, I guess. Maybe not, I don't know.
For the time being, it still needs an engine.
Oh, okay, that's part of the answer. And also I was thinking, like, how much do you think that Tesla, who was, we can say, maybe a precursor to all of this, was it, so my question to you is perhaps more philosophical, I think, than, or anthropological maybe. How much of, the Tesla model, was a precursor to this, or was more a push to go in this direction? So do you think that they were, let's say, ahead of time by doing this, and now it's happening everywhere, or they have pushed all the rest of the world and of the vehicle industry to go that way?
I think they were breaking with convention, because the automotive industry, not only I am old, the automotive industry is old, and for a long time it was all about optimizing the things that we have been doing, and to find, for the developers or the engineers, find me 5% here, find me 2% here. I mean, because everything has already been optimized to a great degree, and nobody really was willing to break with some of the fundamentals that I was illustrating at the beginning of the talk. So the big credit I would give to Tesla is that they started from a clean sheet of paper. And I wasn't there, but I think they really looked at what does it take, let's say, to make mobility more sustainable in the long run. Because what we see are the cars. What we don't see is the IT structure behind. What we don't see, maybe, is as well that they offer batteries for your home, to store the energy there, which is then integrated into the Tesla supercharging, etc. network. What we don't see is so they built a lot of things as an ecosystem behind that we don't see. And the car is, it's a little bit, if you say you're looking at it from a philosophical manner, right? I look at this and say it's a little bit like the mushrooms in the forest. What you don't see from the mushroom is the whatever they call that, mycel, the stuff that's in the ground, and that's connecting all the little things that they can see that are growing out of it. So I think Tesla has a lot of things behind the surface where they rethought the way that cars are designed and made. Now, on the other hand, it's not only Tesla. So your point about a push or a trigger event is probably true, because then you can see companies like Lucid or whatever in the US, and many companies in China that then have taken this approach and say, hey, wow, if we actually break with the convention, we could do this and this and this. So it has sparked a whole wave of ideas and activities, including maybe, we've seen the Xiaomi car and so on. So it is changing, it's breaking convention. And that is probably a good thing in the end.
Certainly for one person pocket.
Okay, I avoided a certain name, right? I just said Tesla in a neutral manner, because Tesla is not just one person.
Other questions? Yes.
Thank you.
Well, thank you.
Thank you very much for a really insightful talk. So again, my question is a little bit philosophical. So along with the development of technology, I think it's equally important to change the psychology of people and make them trust more in the technology. So is this something you guys plan to address in, maybe not now, but in future?
Wow. what can I respond to that? Because that's probably a lot depending as well on, let me say, your personal view of the world, right? So I want to be careful with my answer. But first I agree with you. I think we need to change our view of, let's say, mobility, cars, in principle life, or our consumption as a whole. Because remember my first slide, I said, we have had 20 years of linear growth. If you kind of keep going forever, something's going to break, right? Whatever laws of thermodynamics still apply. So from that perspective, we can all rationally see that. But emotionally, it's very hard, right? And you strike some interest in me because I find this question very relevant personally. Okay, so I will not go so deep, but actually there are plenty of societal or sociological whatever research where you can show that we very quickly adapt to good things, taking them for granted, and then ask for more. But then when you ask people to give away something that they had, it's extremely hard. And it's not just, a matter of, let's say, balancing financially or something. I give you 10 euros, you give it back, you still have €0. But I give you 10 euros and I ask you to give 10 euros back. Giving back feels twice as hard as getting it feels good. And that's where I'm totally with you, but I think a lot of politicians in this world would like to have an answer to this. Because from a rational point of view, we know that's what should be done, but practically speaking, nobody knows how to convince people to actually willingly do it without putting on yellow vests and so on, you know that.
Thank you.
Other questions? Any other question?
I also think we're doing well in terms of timing, so one more.
Yes, so we're in a radar-biased, perhaps, audience here. And you alluded to the fact that originally we had one radar on a car, and today we have more, and the expectation is many more radars on a car. Could you perhaps join the dots between the things that these guys are doing, the technology behind the radar that goes on the car, to the features and the things that these people might experience when they buy a car in 10 years' time? What's the trajectory for the features that are related to the sort of information that you would get from a radar?
Okay, you mean the number of radars or the types of radars or both?
More for me is it's to relate the increasing information that we get from the radars to features that the people drive and can feel. So for us, we understand the technology underneath, but what does that mean to us when we get in a car in 10 years' time? Okay,
a lot to be said about that. Let me start with some basics because I'm not sure everybody's on the same page. Because what brought radars on the car is adaptive cruise control. When I say adaptive cruise control, can you raise your hand? You know what it is? Adaptive cruise control, ACC. Okay, good. Okay, good. Then we're on a common foundation, right? Now actually that was an option, and a lot of people, like if I had asked that question 20 years ago, no hands would have been raised, right? And a lot of people at that time said, why would I need something like that? Today, or for years now, the first thing I do in my car is I put on ACC whenever I can, right? Because it just makes my life easier. But the driving factor actually has been AEB, automatic emergency braking, right? I think you know that, okay? So from that point of view, that has really exploded the fitment of radars on vehicles. And another thing that we've been doing is blind spot detection, again, almost 20 years ago. And it's something that people felt a bit opposed to ACC originally, felt immediately very useful. So what we've seen is that these streams have now come together, and in many cars today we already have a radar cocoon, because adaptive cruise control and a lot of other things are directed to the front. because usually, driving a long distance, it's very one-dimensional. But then driving in a city, you have many degrees of freedom. So you want to have a 360-degree coverage, be it radar, be it other sensors. And that's the shape of things to come. So I didn't explicitly mention that, but of course, when I was showing the BMW or this IP Next ECU, and it said 5 radars, that's a radar cocoon. And then maybe many of you have already a rear camera on your car. Similar to the ACC, you have a front camera that does things, detects things in front of your car. But meanwhile, new cars will all have a camera cocoon as well. And now, one more word on China, because this kind of ACC function, etc., it's mature, it's established, and that's what our traditional customers have been planning on. In China, as I said, consumers are much more keen for new things. You don't have to convince them, oh, why don't you trust this? And so, hey, can I try? Can I try? Can I? And people are pulling on such features. So in China, navigation on autopilot has become extremely popular. That's the thing to have at the moment. So even while you are still responsible, basically the car is driving itself today. And this is I would say, the shape of things to come. Because once you have that on the highway, going off to the next intersection, say, why does it stop now? Why does it stop? Why does it stop? You want to keep going until you're there. And then you are really in urban environments, and you need to have this 360-degree cocoon, multimodal, so radar and cameras, I would say, are given. And then only on top of that, you might have a LiDAR for this, or you might have some other sensing modalities for something else. But that's key. Almost done. I just want to add one more layer, because I was talking about communication, and we've been talking about 6G again over lunch. And for you, I would say you radar guys, I think that's an interesting avenue as well to keep in mind, that in order to detect better, you want to communicate. And I understand that in the communications world, in order to communicate better, you want to detect. So I think we also have to leverage the synergies between detection and communication. Okay, I think we're done, right? Thank you, Guido. And thank you for your questions. Thank you very much.
Thank you very much, Joachim. I think we are done, and now this is a small gift for you for accepting to join European Highway Week and Europe conference this year. So